Welcome students. So in this session we are going to see the Programmable Interrupt Controller. IC number is 8259. Okay. So Programmable Interrupt Controller. What is interrupt? What is the need of interrupt controller? Why the microprocessor needs interrupt controller? Okay. Let us enter into video.
U.com.
So the 8259, that is a programmable interrupt controller. So in our microprocessor, the 8086, we have only one interrupt, that is a INT. The pin is INT. Then that is INT is the pin that is request the interrupt. Okay, the pin that receive the interrupt from external device. Then INTA is the interrupt acknowledge. After receiving, the microprocessor produce the interrupt acknowledge by using INTA pin. So the microprocessor capable of accepting only one interrupt. Okay, so this is a problem here. So to increase the number of interrupt, we are using another one interfacing IC, that is 8259, Programmable Interrupt Controller, in short PIC. Okay, right. So it is act as a manager in interrupt driven system. Okay, so single 8259 can accept 8 interrupt. So we can connect 8 different interrupt. Interrupt means that is the request coming from external peripheral device for some program to request to execute some other program by external device, that is a interrupt. Okay, right. So the 8259 accept request from peripheral equipment, determine which of the incoming request is of the highest important or highest priority. Then it give service to highest priority interrupt first. Okay, it is in first out fashion. So it give highest priority to service to highest priority interrupt. Okay, because at the same time two more device request the interrupt means the device will confuse to service which interrupt. So in order to service any one interrupt, so it produce some priority levels. Okay, so based on the priority, it will service any one of the interrupt, and other interrupts, other requests are waiting in queue. Okay, right. So based on the priority value, then the level currently being serviced, and issue an interrupt to CPU based on the determination. Okay, so in the 8259, single 8259 can accept 8 different interrupt. Then it has the priority levels. So which interrupt is highest priority, which interrupt is lowest priority, that is determined by 8259. Then highest priority interrupt is serviced first, lowest priority interrupt is serviced after highest priority. Then each peripheral device or structure usually has a special program. Each peripheral device or structure usually has special program or routine that is associated with its specific functional or operational requirement. This is referred as a service routine. So what will happen after interrupt request? So if peripheral device request interrupt means, at the time the 8259 find its priority levels. If it is have a highest priority means it will forward the interrupt request to next level to microprocessor. So microprocessor execute the routine. What is routine? So every device has its own routine. Okay, that is a program. After requesting the interrupt, the particular program is executed by the microprocessor. That is called service routine. So if any device, peripheral device access interrupt, so the microprocessor continuously execute its service routine. So that it is called as service routine. That is a one small program. After the completion of this routine, the microprocessor enter into its main program. Okay, right. So the PIC after issuing interrupt to the CPU must somehow input information into CPU that can point the program counter to service routine associated with the requesting device. So how microprocessor find its interrupt service routine? So the interrupt service routine is marked by some vector, that is a interrupt vector. So it is has some address. So after requesting the interrupt service routine address is given loaded into address bus. Based on that, the CPU executes interrupt service routine that is present in the memory. Okay. Then features of 8259. So the features, it has many features. First one, it can manage 8 priority interrupt. Single 8259 can manage 8 priority interrupt. So we can cascade 8259. So cascading means that is we can connect the 8259 in serial manner. Then 8 number of 8259 can be connected. So maximum we can connect 8 different ICs of 8259. So totally 64 interrupt can be possible. In one microprocessor we can access 64 priority interrupt is possible. Okay. So this IC is developed in VHDL method, very high VHDL HTL language. Okay, right. So master and slave option also available. If we connect more than one IC, any one of 8259 act as a master, remaining ICs act as a slave. Okay, right. So these are the features of 8259. Then the 8259 manage 8 level of interrupt request and has built-in features for expandability to other peripheral interrupt controller. Okay, up to 64 levels. So it is programmed by system software as an IO peripheral. The priority modes can be changed or reconfigured dynamically at any time during main program operations. Okay, so these ICs can be programmed as like input output peripheral. Okay, right. Then the priority of the interrupt can be changed according to our requirement. Okay, for example, in our computer we connected 8 different devices. Okay, just such as a scanner, printer, like that. Okay, so 8 different devices are connected. So according to our requirement we can give a priority to these 8 different devices. So according to the priority, the 8259 service the interrupt. Okay, so the priority is configured by the user. Okay, right, that is the important thing. Then the block diagram of 8259. So the 8259 blocks are around 8 blocks present. In right hand side we are having the pin diagram. So consider the pin diagram, it has the 28 pins. So dual in line package. Okay, so most of the pins are data lines, actually 8 data lines, D0 to D7. Similarly IR0 to IR7, that is a interrupt request line, that is a 8 different lines. So we can connect 8 different interrupt to 8259. See the block diagram. See these are the common blocks used in all the ICs. Okay, these two are the common blocks. Okay, data bus buffer. What is data bus buffer? Data bus buffer is to transfer the data between microprocessor and 8259. It is a bidirectional tri-state 8-bit buffer. Okay. The next one is a read-write logic. This is also present in all the blocks. So read-write logic receives the control signals such as read, write, chip select and A0 from 8086 microprocessor, and it's control the entire blocks present in the 8259. Okay, according to the control signal, it will control the entire blocks. Then cascade buffer or comparator. So cascade buffer or comparator, that is used to connect different 8259 in cascade manner. These control signals are used to connect in cascade manner. Then another one is there is a control logic. This control logic is for interrupt purpose. So this control logic is connected with the 8086 microprocessor interrupt pin and INTA pin. So the microprocessor has only one interrupt line, that is INT and INTA. So these two pins are connected with this control logic. According to the control logic, so it will control the remaining interrupts. Okay. Then interrupt request register, IRR. So interrupt request register is a 8-bit register. It can store 8 different requested interrupt levels. Okay, right. So this interrupt request register store the requested interrupt from external device. Then priority resolver. Priority resolver receives the input from interrupt request register, and it is resolve the priority levels, different priority levels. Then it is given to in service register. After resolving priority, that in service register store the servicing interrupts. Okay. Then interrupt mask register is used to mask some interrupt. So if you want to hide some interrupt, we are enabling that values in interrupt mask register. So these are the registers. These registers store the different levels. Interrupt request register store the incoming request. In service register store the interrupt of servicing. Interrupt mask register store some hidden interrupts. Okay, so these are the block diagram of 8259. We will see the detailed discussion. First one, interrupt request register, in service register. The interrupt request register, that is the interrupt at the IR input lines are handled by two registers, that is a cascade interrupt request register and in service register. So IRR is to indicate all the interrupt levels which are requesting service, and ISR is to store all the interrupt levels which are currently being serviced. So currently being serviced is stored in service register. Requesting levels is stored in interrupt request registers. Next one is a priority resolver. This logic block determines the priorities of the bit set in interrupt request register. The highest priority is selected and strobed into corresponding bit of in service register during INTA sequence. Actually, this block is to find the priority levels. The highest priority is selected and strobed into corresponding bit of in service register. So in service register, in service register, the highest priority bits are given. Okay, during interrupt acknowledge sequence. When the microprocessor acknowledge for the particular interrupt, at the time the high priority interrupt is given to in service register. Then interrupt mask register, IMR. Interrupt mask register store the bit which disable the interrupt line to be masked. So the IMR operate on output of interrupt request register Masking of highest priority interrupt will not affect the interrupt request line of lower priority. Okay, so we can mask any interrupt by using interrupt mask register. Then data bus buffer. So this is a 3-state bidirectional 8-bit buffer is used to interface PIC to system data bus. Control words and status information are transferred through the database buffer. Then data lines D0 to D7. These wires are connected to system bus and are used by the microprocessor to write and read the internal register of 8259. Then A0. This pin acts as a conjunction with the W, that means read write signals. It is used by 8259 to specify various commands, words. Microprocessor writes the status and the microprocessor wish to read. Okay, so this is a pins used in a 8259. Then read signal, write signal. Okay, the read signal, when this first one, the write WR is a write signal, is asserted, the 8259 accept command on data line. Therefore the microprocessor write to 8259 by placing command on data line and asserting this signal. Okay, so WR is mainly used for write and the RD is used for read the 8259. Then INT, this signal is used whenever the valid interrupt request is received by the 8259. So it is used to interrupt the microprocessor. So the INT pin is connected with 8259. So 8259 receive all the interrupt and it is given to microprocessor through INT pin. Okay, right. Then INT is a acknowledge pin. So after the microprocessor receiving the interrupt, it acknowledge the interrupt by using INTA pin. This is a input to 8259. Okay, right. The next one is a IR, interrupt request 0 to 7. So it is an interrupt request line is executed by the peripheral device when one of the signal is enabled. Then CAS 0 to 2, these are the cascade signal to enable multiple 8259 chip to be chained together. Then SP bar EN, so this is a signal used in conjunction with the CAS signal for cascading purpose. Okay, and these are the signals used in 8259. Next one is programming. Okay, so to program 8259 we must program two things. First one, initialization command word. After the programming of initialization command word, we have to program operational command word, OCW. Okay, so the 8259 initialized using ICW commands. The ICWs are used to set up proper condition and specify RST vector location during initialization. Okay, itself. The address of each ISR for each interrupt device are fixed. As per the requirement, these addresses are spaced 4 to 8 bytes apart. Okay, any portion of the memory may be used for this. So 8259 can be initialized with 4 ICWs. The first two are essential and the remaining two are operational depending on the modes used. The OCWR, that is a operational command word, are used to perform the function like masking interrupt, setting of status, read operations, etc. The 8259 can be set to operate in various modes using 3 different OCWs. This OCW can be written into 8259 any time after initialization. Okay. So the initialization command word is mainly used to initialize the 8259 Okay, and after the initialization, the OCW is initialized. The OCW command word is used to perform the mask, the interrupt, and the setting of status read operations and other operations. After initialization, we can write operational command. Okay, then we will see one by one. So actually we are having a 4 initialization command. So the first one is initialization command word 1. So this is a 8-bit command word. See the individual bits. The first bit IC4. So if this bit is 1, then ICW4 is needed. If it is 0 means ICW4 is not needed. Okay, right. ICW4 means that is the initialization command 4. Then second bit, it is SNGL. So if it is 1 means the 8259 act as a single IC. If it is 0 means 8259 is connected with other 8259, that is a cascaded connection that indicated by SNGL. Then ADI. So actually this is ADI is a call address interval. If it is 1 means the address interval is 4 bits. If it is 0 means the interval is 8 bits. Okay, right. So call address interval. Actually the every interrupt service routine is stored in the memory with 4 or 8 bit apart. Okay, the next one is a LTM. LTM means level triggered mode. If it is 1 means level triggered mode. If it is 0 means edge triggered mode. What is level trigger? What is edge trigger? So level trigger means consider one pulse. So this is a pulse. This. Okay. So in this pulse, the level trigger means the particular device is triggered at the level. Level means the horizontal line. Triggered at the horizontal line in the pulse. Edge triggered means it is triggered in the vertical lines. So any one of the vertical line, rising edge or falling edge. Okay, right. So in that that is a edge triggered mode. Okay, next one A1, A2, A3. Okay, right. So this is the interrupt vector address, that is the address of interrupt vector. Okay, the interrupt service routine address. Okay, right, that is placed in these 3 lines A0, A1, A2. Okay, this is a ICW1 initialization command 1. So initialization command where command 1 indicates so ICW4 needed or not needed, then the IC is connected in single or cascaded. Okay, then call address interval. Okay, then it is level triggered or edge triggered. Okay, these are the things indicated by the ICW1. Next one, you are going to see the ICW2. The ICW2 is fully assigned for address, interrupt vector address. Okay, it is a 8-bit address. The interrupt vector address is mentioned in the ICW2. In previous one, the interrupt vector address is a 3-bit. Okay, right. So actually this is for mostly 8085 mode only. Okay, that is important point. 8085 mode only, in not for 8086. Okay, so if we are using 8086, so we are using interrupt vector address by using ICW2. Okay, all the bits are indicate the vector address. Then ICW3. So ICW3 is mainly used for master and slave devices. So if it is a master means these 8 bits are mainly for interrupt request input as a slave. If it is 1 means IR input has a slave. If it is 0 means IR input does not have a slave. Okay, right. So interrupt request input is slave means that is all the bits are 1. And it's not slave means all the bits are 0. Okay, that is in master device. In slave device we are having only 3 pins. Okay, if the 8259 acts as a slave, so it needs a slave ID because we are using more than one 8259 connected in cascade manner. So one device is act as a master and the remaining device acts as a slave. So if the more than 2 device act as a slave, then that will need some slave ID, then only we can identify the interrupt coming from where. Okay, so slave ID is indicated by IC3W in slave device. Okay, so first 3 bits is mainly used for the slave ID. Okay, it's a slave ID, so we can connect 8 device by using this slave ID. Okay, 0 to 7. Okay, this is a ICW3. Next one is ICW4. So the ICW4 has some specific functions. Actually 5 different functions are available here. The first one is MPM. So MPM means if it is 1 means that is a 8086 mode. If it is 1 means 8086 mode. If it is 0 means 8085 mode. Okay, 8085 mode and 8086 mode. Actually this 8259 can be connected with 8086 or 8085. Okay, so if it is connected with the 8085, so the ICW4 first pin is set to 0. If it is connected with the 8086, the first bit set to 1. Then AEOI, ATO EOI. Okay, if it is 1 means that is a ATO EOI, if it is 0 means that is a normal. Okay, next one is a 2 bits combined together, that is a buffer and that is a master slave. M represent master, slave S represent slave, BUF represent buffer. If it is 0x means non-buffered mode. Okay, buffer pin is 0 means that is a non-buffered mode. Then if it is 1, here it is 0 means buffered mode, that is slave. So 0 indicates slave, 1 indicates master. Here 1 indicate in buffer mode, 0 indicate non-buffer mode. Okay, right? So this is combined together, so it perform 3 different operations. Next, the last bit is D4 SFNM, that is special fully nested mode. If it is 1 means the 8259 acts as special fully nested mode. 0 means non-special fully nested mode. Okay, so these are the one of the mode used in 8259. Next one is a OCW1. So after issuing ICW, we are issuing OCW. So OCW is an operational command. So here the issue with A not equal to 1. Actually here another one bit is present, that is A not. Okay, it is always 1 in OCW. So that is to mask interrupt. To enable all the IR lines, the command word is 00. Okay, right? So actually this is a OCW is a mask, interrupt mask. Okay, so 1 means mask set, 0 means mask reset. Actually we are having the 8 different input lines, interrupt request lines. Okay, 8 different interrupt request lines. So if you put D not equal to 0 means the IR 0 line is masked. Okay, so it is hidden, so that interrupt cannot work. Okay, right? So if it is 1 means if you put all the bits are 1, then all the interrupt are masked. Okay, so according to the requirement, we can mask any interrupt in IR0 to IR7. Okay, totally we have 8 interrupt lines. So in the 8 interrupt lines, we can mask any one interrupt by using this OCW. So OCW1 is mainly for mask the interrupt. Then OCW2. Right command here, A0 is also 1. Okay, A0 is also 1. Then D4 D5 is equal to 0 is interpreted as OCW2. Okay, R means rotate, SL means select level, EY means end of interrupt. Okay, so here we will see. Okay, right. First one is first 3 bits combined together to form a different levels. Okay, so L1, L2, L0. Okay, IR level to be acted upon. Okay, that is a IR level. So we are having the different 8 levels of interrupt request, that is mentioned here. Then D3 D4 is 00. Okay, so it is interpreted as a OCW2. So D3 D4 is mentioning OCW2. Then here we are having the three bits, that is a rotate, then select level, then end of interrupt. These three are combined to produce 8 different operations. Okay, it is 001 means non-specific end of interrupt command. Then 011 means specific end of interrupt command. Then 101 means rotate on non-specific EOI, rotate in automatic EO, automatic EOI. Okay, then 000 means rotate automatic EOI clear. Then 111 rotate specific EOI. Then 110 set priority command. 010 no operations. So these are the ICW2. Then ICW3 is used to read the status of the register and to set or reset the special mask and polled board. Here A0 should be 0. Okay, here A0 should be 0. In previous two OCW, the A0 is 1, but in OCW3 A0 is 0. Okay, right. So here this OCW3 is mainly used to read the status of register and set and reset special mask and polled mode. Okay, first two bits are combined together to form 4 different operations. Okay, read register command. Okay, first two digits is mainly for read register command. So 0001 means no action. 10 means read interrupt request register on next RD pulses. Okay, then 11 means read in service register. Okay, so 010 means read interrupt request register, 11 means read in service register. And here D2 is P, that means poll or no poll. If it is 1 means that is a poll command, 0 means no poll command. Then D3 D4 is 01 here. Then S double M and E S double M, these both are combined together, that is a special mask mode. Okay, so here we are having the 4 different operations. 00 and 01 means no operation, 10 means reset special mask, 11 means set special mask. Okay, so 010 means reset, 11 means set. Okay, D7 is 0 here. Okay, A0 is also 0. So this is a operational command OCW. Okay, right. So this is the end of the session. So I hope that you all are understood about 8259 interrupt controller, programmable interrupt controller. Okay, so thanks for watching. So in exam point of view, this question also very large portion. So block diagram and block diagram explanation, then you have to draw around 6 command words. So just concentrate on command words and block diagram and reduce the theory, okay, to consume the time, right? Thank you, thanks for watching.